everything onto YouTube, so that should be up tomorrow. So, alrighty. So white blood cells part 2. So we're just focusing on eosinophils, basophils, monocytes, and then there's just a couple other leukocytic cells that we'll look at. I threw these key terms on there again, only because I just want you to be really comfortable with the terminology, and they'll probably show up again on the test. And then I also threw this picture up on there for you guys because I think it's super neat. So you could like make a big blow up of it and put it on your wall or something. All right, so granulopoiesis, and then depending on what book you're reading, sometimes they call it granulocytopoiesis, but it's basically the same thing. All it is the hematopoiesis of granulocytes. That's all it is. So this is all happening inside of your red bone marrow. And this bottom part here, I've already tested you on all this, where you got the stem cell, which goes to the myeloblast, the promyelocyte, where you had to put that all in order on the test. I'm not going to retest you on that. I just put it back on here just as a reminder of like all of the things you've learned so far and how smart you are. All this information is stuff we've already learned. So we're just kind of adding more to what you already know because you're all smart. Should I wait for a second, or do you guys got all that? You all good? Chloe, it was good to see you this weekend. I wasn't sure if I had accidentally kicked you out or if you just left the thing.
No, it actually kicked me out because my Wi-Fi was so bad.
Oh no, I'm sorry. So for you guys that didn't come Saturday, we were working on math. So I'm working on putting together some math worksheets for you guys, just to work on for extra stuff, like if you wanted extra practice for some of that. So hopefully I can get that finished this week sometime and I can send it to you. But we'll probably do math again Saturday if you guys want to. If you want. So I just, I thought this picture was really neat. I found it on Pinterest again, but it must have been some sort of project that somebody did for science class, but it goes from immature to mature. And I just thought they did a really good job. If I was their teacher, I would have given them an A. But basically it shows the little baby cell, and as it matures, it loses its basophilic color, and all of the little granules start to increase in number, and the chromatin is more condensed. I just thought it was a really nice representation of all the changes that they go through. Neutrophil has a little bit more of a process, but. And then these are just some like real life pictures. In person, we would be doing more matching and identification. But the way the tests are structured online, I'm not going to be having ID like that at all. So I don't want you to start stressing about all of these pictures and trying to make flashcards. You know, I would use them for your own reference. But as far as the test is concerned, I'm not putting them on the test because I would prefer to do this lab in person with you before I expect you to be able to test on it. So when we get back, we'll do this lab together. We'll do a virtual lab too, but I would, before I test you on it, I actually want to be there like right next to you and hanging over your shoulder going, this is a neutrophil, this is a eosinophil, this is a myelocyte. So while I love this picture, I don't want you to overstress and start making flashcards and focusing on the wrong thing for this test. So Let's talk about our eosinophils a little bit. So they do typically stain red. Um, and then depending on what species you're looking at, the granules are going to look very different. But just like the neutrophil, all of their lobes, everything is connected with this strand of chromatin. And the pictures on the right, now on my screen they show up a little bit different colors, but in person, when I display them on the board, they kind of all tend to look really pink or purple, you know, depending on what room I'm in. Um, so what I'm doing for the test is I'm not using these pictures. What I'm going to do is use the description. And you'll see what I mean when we get to the next slide. But when you look at the book and they say this is an eosinophil, it's going to be like super, super red. So what they've done is they've super stained that one so it is like a brilliant red and you're like, oh my god, yes, that's an eosinophil. But in real life they don't always look like that. So this is what they're typically going to look like. These have been stained, but they haven't been they, you know, in the like 10 to 15-second dip. The ones that you're seeing in the book are a little bit modified. They've accented that red so it's really noticeable, and they also left it in the stain much longer so it's kind of dramatic of a color. But in real life, it's not going to look that dramatic. Looks more like this. So as far as the test is concerned, what I'm going to do is I'm actually going to talk about it. Like a example test question would be, this particular species has round granules with a light blue cytoplasm, and then you would have the choices of feline, canine, bovine, equine. So when you're studying for this, focus on the words, not so much the picture. The pictures are just for your own reference, but I'm going to be using the words, not the pictures for the test. And then the cats, their little granules are more orange and they're rod shaped. It actually kind of affects the shape of it too, so it's not as circular, so it's kind of oblong in some cases. On my screen, it's showing up kind of orangish or pink, um, but I can't assume that everybody has the same kind of screen resolution, and a lot of people in second and third period said that theirs is just looking completely pink, which is why I'm going with the words, not the pictures, because I just don't think it's fair to try and make you guess what color it is. I've actually had one student in the past that was colorblind, so that was challenging for her. I felt bad. And then the horses, you can really tell the difference in their granules. They're very big, they're orange, and they're just large and globular. And then if you are a ruminant or a camelid, they look exactly the same, and they have small, round orange granules. That picture's a little fuzzy, but you can kind of make the granules out a little bit. I love the equine one. It reminds me of that bubble gum that that you get in the gumball machines that tastes good for like 30 seconds and then it goes away. Then it just turns to like hard rocks in your mouth. And then we have this little guy. He has to be different. Of course, there's always got to be the one. This is a vacuolated eosinophil that they found in a greyhound. So what's happening here is it lacks the myeloperoxidase, which stains it red. So he actually looks more like a monocyte with a band neutrophil because he doesn't stain. Um, so you can see this in some of your sighthounds, greyhounds specifically, and also some golden retrievers. Now it's not all of them. It's just every once in a while you might get a particular sighthound or golden in, and they just don't stain. So, and there's nothing wrong with them. It's just, and I tried to look up why they have them. Is it like something genetic? And it's just random. It's just super random. So, just kind of strange. You want me to leave that up there for a minute? If I'm going too fast, by all means, speak up. Okay. Then that website that I was telling you about the other day with the cute stuff had some really cute flashcards available. So I put them on here for you guys. So this one is obviously for your eosinophils. I need to move this because it's like in my way. Um, but they have a killing strategy. So they go to the battlefield, which is called chemotaxis. They recognize the targets and then they phagocytize. But their biggest thing that they do is they perform a chemical attack. So they release all of these toxic granules, and that's how they kill stuff off. So put those on there for you. So they do have a life cycle. They spend about 3 to 8 hours in your circulation, and then they enter into the tissues. So just like the neutrophils, once they get into your tissues, they're never going back into circulation. So they're just going to live their life out there, or if they come into contact with anything that they need to fight off, they're going to be destroyed. And then the tissue macrophages come in and they phagocytize the dead. And if you have a lot of them, we call that eosinophilia. And if you have a decreased amount, it's eosinopenia. So they got a few jobs. Let's see. Let me put their jobs in there. So they are part of the inflammatory process. So if you become sick or you get an allergic reaction to something, these guys are going to show up there. They're also part of the immunity process. And the other thing that they do is they could do a little bit of phagocytosis. Not a lot, but they can do a little bit. So these guys typically like to live where you're really exposed to a lot of different things. So they hang out on your skin because we like to touch all of the things. And so they're there for us as protection. Also in your lungs. So if you inhale something, that wonderful yellow snow that we have floating around, the eosinophils will come there and try and clear that all up for you. And then it also hangs out in your GI tract. So that really helps, like if you get any kind of parasites, anything like that, these guys will be there. Or if you eat something that's not so great for you, maybe you got something with, you got food poisoning. So these guys are going to come in and they're going to try and help fix you a little bit. I'll leave that up there for a moment. Let's clear that. So here's function one. So this is, I like to think of it as a bump knee. So when you bump your knee and it opens up, you got bacteria coming there. So they get really attracted to that. Maybe it's some sort of anaphylactic reaction. And when they get there, they kind of, oops, what? Ooh, why is it doing it? Oh, I'm leaning on my mouse. Sorry. Let me go back. Sorry about that. So these guys are going to go ahead and release anti-inflammatory substances. So that'll help decrease that inflammation that's on that spot. So I got, just like, for example, I got bit by a spider this weekend, and so they came in, and the basophils make it inflamed, and then the eosinophils come in and try and like decrease the inflammation. Stupid spiders. And of course it happened, I was sleeping and it woke me up. Like I woke up just like scratching my leg like crazy. And then I had to strip the bed because I was like, I need to find, I never found that spider, but I'm pretty sure it was a spider. So mean. Oops. Let me undo that. Here. I'll do it. All right. So here's immunity. So they can do a little bit of immunity help. Now we're gonna be getting into the immunoglobulins more so when we get into the leukocytes or the lymphocytes. But IgE starts to show up in here. So he's an immunoglobulin, kind of the one that we actually saw when we watched all the phagocytosis going on with that. It was a parasite. So what happened there, and the whole reason that they were attracted to it is because it had put little IgE things on the ends of it. So it kind of was like a little beacon. So all the neutrophils and everybody knew who to go attack. So that's his whole purpose, is he kind of just like puts the little landmines on the things that are, needing to be destroyed. And then finally, they can eat a little bit. They can do a little bit of phagocytosis. They don't do a whole lot. Their whole job is mostly to just explode because their granules are really toxic. But they do have lysosomes in there, so they do have a little bit of phagocytosis going on, just not to the extent as monocytes and neutrophils. But they can do a little bit. Just a little. So this one, I really love this. And I'm going to put this on the top. And I'm going to leave it up here. Wait, I need this in white so you can see it. So I'm not going to use all of them, but I can't see it. I can't see what I'm writing. So the A, this is when they show up. So adrenal insufficiency. They might show up with lymphoma. The second L, I'm not worried about that one. That is more of a human type of thing that I don't need you to concern yourselves with. E, eczema. I'm also going to put any other skin irritations. So in animals, we don't so much call it eczema. Humans, it is, but dogs can get hot spots. They can get any kind of other skin irritations, so they'll show up then. Respiratory causes. G would be GI issues, usually enteritis. It could be parasites too, so I'm going to throw that on there. I, infections. So parasites again, or any infection. I don't need you to worry about C either, because that is more of a human-based issue, like all the collagen vascular diseases like systemic lupus erythematosus, Strauss, all those. But we don't really see that too often in animals. So don't focus too much attention on that. I just thought it was a really neat little way to remember. Oops, undo. No, redo. There we go. I'm going to leave that up for all of them so it stays on the top. Then we got our basophils. So these guys stain more blue. They're also multilobular. And it's really hard to tell the difference between basophilia. Oops, I need to change my color back to red or something. Basophilia and basopenia. The reason it's so hard to tell the difference is because there's so few of them. So you would have to really be looking at this animal every single day and pulling their blood, or every other day. So let's say every time you run their blood work and you do a smear, you're seeing 2 basophils. But then one day he has 4. Now, if this isn't an animal that I see every day, I wouldn't think anything of it. But for this animal, it's actually basophilia, or maybe he drops to 0. And ordinarily I would think, well, you can have 0 basophils, but in this case, this guy always has 2, but now he has none, so now it's basopenia. So really it's hard to tell the difference between basophilia and basopenia because you just don't have enough to really make it matter. So their whole job, whoops, where's my thing keeps going away on me. So their things can contain histamine. I need to move this up. And also heparin. So what happens is you have some sort of immune response. Histamine gets released, and all of a sudden you have this huge allergic response. And your body's like, well, you need more blood because we need to bring more guys to help you. So heparin increases the blood flow so you can have more blood. So then once that's all initiated, it also contains some antihistamines, and they're going to bind to these allergen and then trigger all of them to be released. Wait, let me make sure. No, I'm a liar. I'm a liar. Can I change that? Cross that out, guys. Immunoglobulin E. I think I may have to move into another room tomorrow. I hear my husband talking and it's throwing me off. I tell him to move in another room. So what these little guys are doing is just attaching to the ends of whatever's the irritant is, and it's putting those little beacons on there for them to release and trigger that histamine release. IgE. Oh, I didn't want to do that. Undo. I just want to take off these. There. I want to leave that other one up. So canines are really hard to tell the difference. Like I said, in your book, they're going to be these beautiful blue things, and like Lab Pro, we told you they look blue, and they're always going to be blue, but that's not the case in real life. So in dogs, they actually look like a ribbon. So sometimes they can be kind of mistaken for a neutrophil, but there's not distinct lobes. It's more like a ribbon. Some of them you can see some granules. Sometimes you'll see some granules in a cat blood, but if it's a healthy animal, you really shouldn't see any of these. So I just need you to be aware, like, they don't always look like the book. because those are like the, oh. Here is a feline one. Sometimes they look like they have vacuoles, um, but them you can actually see the granules much better. Much, much better. This animal I feel like has something going on because those red blood cells look a little bit agglutinated. Here's just some other pictures. Equines are pretty dramatic. They're really, really dark. Bovines look a little more pink. And their killing strategy is pretty much the same thing. They're going to the battlefield, recognizing the target, and once they recognize it, they're going to attach those little IgE molecules, and then they just explode and release all of their toxic granules. They're so dramatic. And we got our monocytes. So these are ones that are a little bit, they got one different term, so it's not monocytophilia, it is monocytosis if it's an increased amount. And if you have a decrease, it is monocytopenia. And he is the biggest, and he has vacuoles, so he goes to war and he starts eating all the things. Monocytosis. This next slide has a lot of words on it. But basically what I'm trying to get at is to explain to you that these guys can mimic a lot of different things. They can look like a neutrophil. Sometimes they look like band cells. Sometimes they look in like an equine, they could look like a lymphocyte. So they're tricky because they have that pleomorphic mononucleus. So it just changes shape. So he tries to be a little tricky, but the best way to identify these guys, if he's trying to trick you, is kind of look at the red blood cells that are around it. And if you can fit like 3.5, maybe even 4 red blood cells inside that one, it's a monocyte, and he's just trying to trick you with how it's kind of morphed. So let me show you what I mean by that. So trying to ID these guys, like the canine one, you know, if I didn't know any better, I would look at it and go, oh, band cell. But then I look next door to him and I see these red blood cells and see how tiny they are compared to him. And I could probably fit like 3.5 in there. That is definitely a monocyte. Felines that you can kind of see in this one is a really nice one where you can actually see the vacuoles. Equine really looks like a lymphocyte, but he's huge. And then your bovine is also super, super big. So I just wanted to throw those all together so to show you that they try and be little tricksters on you. So here's their job. So they're also helping out with the inflammatory response. They do a little bit of phagocytosis as well. They really like to eat all of the things. So I'm going to just put phagocytosis. And they have another really unique job. So what they do is after they eat it, it really reminds me of when my kids were little and they'll be like, I just licked this. What did I just lick? Or I ate this. What did I eat? So what they do is they eat it and then they go find a lymphocyte and they show it to them. So if the lymphocyte says, yeah, I know what this is. You've already had flu type A. I know how to fight it and it's going to send out whatever warriors it needs to send out. If it doesn't recognize it, then it's going to go ahead and I like to think that they go off to the lab and try and figure things out. But if they don't understand what it is, they're going to try and figure it out. And then they're going to memorize it. So the next time their body comes in contact with it, they're going to be able to fight it. So they don't live long in your bone marrow, but they move to the tissues. really quickly, and they live there for like 100 days. So they kind of they live a much longer time. And then the biggest other biggest thing I need you to know from this page is the monocytes and macrophages. They kind of get put in this one big group called the mononuclear phagocytic system. So this is just a system that really likes to do phagocytosis. So they do a lot of eating. They're your eaters. But they're pretty cool. Somebody told me about what was it called? Oh, I totally forgot. I'll have to watch the recording. But she told me about a YouTube video that's out there, something about the body or something that it talks about all this stuff, and it's like a movie, not that, oh, I can't remember what it was called. I should have wrote it down. All right. So here's just another one of those flashcards. So he also does chemotaxis, he does phagocytosis, and this guy has transformer mode, so he could turn into a macrophage. And then we got, oops, let me get rid of phagocytosis. How did I leave that on there? Annotate, erase, or get rid of that. Okay. So this one, that's another one with a lot of words. So if you ever come across a chart that says a patient has marked histiocytosis, histiocytes and histiocytosis is basically just this huge umbrella term. So they looked at it and they're like, I can't really tell if this is a monocyte. I can't really tell if it's a macrophage. I can't really tell what this is. So they just deem it histiocytosis. So they're not normally in the blood, but there's some sort of phagocytic activity going on. So you can see it in reactive or just you can see it in neoplasia, but usually it's something immune mediated. So, or it could be a protozoal infection. One specifically that the book talks about a lot is cytozoonosis. Zoonosis. So that's a protozoa. IMHA can cause this. So you got histiocytes that they look abnormal. There's also something called dendritic leukemia, which is just a rare form of leukemia that can start to show these. But basically what I need you to know is histiocytes, super umbrella term. It's not saying that this animal has cancer for sure. It just says there's histiocytosis going on and it needs to be investigated a little further to figure out what is happening. I think, oops, let me, how come it's not allowing me to, there we go. So I'm going to go back and forth between the two pictures to explain this better. So here is histiocytes. So everybody kind of is staying within their own cell. They still have this outer shell. Everybody's together. Now it changes when you get to a mast cell, which is what's next. So this is usually some sort of neoplasia, lymphoma, mast cell tumors. So what happens with these is these guys tend to explode. So mast cells explode. So when you're looking at them, it's going to look like this. So this here, let me draw in there. I think the words get a little confusing. I would rather draw it. So this used to be a cell over here, but he exploded and he kind of, his cytoplasm just spilled all over here. So all these other cells came in to try and clean it up, but now they've also picked up the cancer and they're spreading it. And what's going to happen is they're going to explode, and that's how this cancer can spread so rapidly. So I just want to go back to this other picture. I should have put them side by side. So you can see the, see these guys are all together. Nobody's spelling out. This one looks like a little suspicious, but not too bad. But then you get to mast cell and it's spilled out. Does that make sense to everybody? Okay. So he's maturing in the tissues, he recognizes the target, and then he explodes. That's what a mast cell does. And that's it. So this upcoming test, we'll do the review tomorrow. I'm going to make us a Kahoot tonight, but this test is going to be pretty short, so probably a lot of terminology type questions. And like I said, when you're studying the different kinds of eosinophils with the species, focus on the words, not the pictures so much, because I'll be using just the words for that. So if you make flashcards for yourself, okay, thank you. So, any questions on this stuff? No? We'll wait for Gabby to get back in, then we'll tell her we're calling it a day. Let me just stop recording.